Now I want to talk about the properties of logarithms. So these are things that you should remember. First property is the addition property. The multiplication becomes addition. If you have the log of some base of a value plus the log base of another value, what you can do is write them as the log of the same base, but the values are multiplied. So let's say that I have log base 6 of 8 plus log base 6 of 4. How you can write that is log base 6 of 8 times 4, which is 32. So log base 6 of 32. With subtraction, what happens is that you take these values and you can divide them. So let's go with the same numbers. Log base 6 of 8 minus log base 6 of 4 turns into log base 6 of 8 over 4, which is 2. If you have an exponent and you take it on some value and you take the log of that value, what happens is that the exponent comes down. So let's go with log base 6 of 8 squared. What happens to the 2 is it can come down as a multiplier. So it's the same thing as 2 times the log base 6 of 8. And now we're going to use those to combine and also separate logarithms. Log base 3 of 20 minus log base 3 of 4, what we know is that is the division. Log base 3 of the first 20 divided by 4, which equals log base 3 of 5. Same base, log base 4, 60, and then log base 4, 16, subtracting them turns into a division problem. Log base 4 of 4. And then I guess they might have you do this in the book, is actually say what does this equal. Obviously you would say, alright, 4 to what power equals 4, and you know that x equals 1. And then with this we have the same log base 2 of x, or 2, and then plus log base 2 of y, and then we just have this number out in front. Don't worry about that. Just worry about this part and make sure you still have 3. Actually, no, I was worried about that. Now 3, since it's a multiplier out in front, was originally an exponent. So what I can do is write this as log base 2 of x to the third plus log base 2 of y. Now that I turn this into an exponent, what I'm going to do is realize I have log base 2, and it's an addition. So what we can do is when it's addition with the same base, that's 2 right there, not a z. you multiply those values. So x to the third times y is multiplied. Same thing here. You see that you have a multiplier out in front. This was originally an exponent. So you say, alright, I have log base 5 of x to the 6th plus log base 5 of y. Same log base 5, x to the 6th, and y, and there's addition, so you're going to multiply. Log base 5 of x to the 6th y. Okay, so we don't have a base. What we realize is that the base would be 10. Okay, but when the base is 10, we don't need it, so we'll just leave it out. What we realize is this multiplier was originally an exponent. So we have log of 2 to the third plus log 4 minus log of 16. When they're adding, you multiply. When it subtracts, divide. So what we can do is say it's log of 2 to the third times 4 divided by 16. And then we can simplify. Log of 2 to the third is 8. 8 times 4 is 32. 32 divided by 16 is 2. So will just be the log of 2. Now we're going to expand. We have log base 5 of x divided by y. And when we're expanding, division turns into subtraction. So we can write it as log of 5 of x minus log of 5 y. Same thing here. Division, when expanding, turns into subtraction, so it's log base 7 of t minus log base 7 u. What you see right here is multiplication. Multiplication, when expanding, becomes addition. So you can say it was originally log base 2 of 7 plus log base 2 of b. We have a multiplication right there, right here. We don't have a base, so we have to assume it's 10, where we know it's 10. And then we have this exponent. So let's split them up by the addition first. So log of 3 plus log of r to the 4. And then when you're taking the log of r to the 4 can come down. So it's really log of 3 plus 4 times the log of r. Same thing here. Split the multiplication through addition. Log of 4 plus log p to the 3. Then realize 3 needs to come down. Log of 4 plus 3 times the log of p. Now what you need to realize first is that the 2 applies to both the y and the 3. So when I split this up, it's division, right? But so that will turn into subtraction. But you have to apply this 2 to both the y and the 3. So I'm going to say it's the log of y squared minus the log of 3 squared. And then the exponent comes down on both. 2 times the log of y minus 2 times the log of 3. These have different exponents, but you can split them first through the addition. Log of base 7 of a to the third plus log base 7 b to the fourth. Both the 3 and the 4 need to come down as multipliers. So it's 3 times the log base 7 of a plus 4 times the log base 7 of b. And this is your homework. Please do it.